Okay, so now we're going to look at rational exponents. So exponents that are fractions. What does that mean? Well, you're already familiar with one of them, the square root. So remember that the square root of 4 is 2, right? And so that means that 2 times 2 is 4, right? So that means that if I consider 4 to have an exponent of 1, then 2 must be 4 to the half times 4 to the half. Because from our exponent laws, if I add these two together, right, then I get 1. All right, so 4 to the half plus a half is 1. That means that this square root actually means that it's x to the 1 over 2. Okay? And this can be expanded to any other root. That means I can have lots of different roots. So this is a square root, and it has a little invisible 2 here. We don't write it, but it means it's something that multiplies itself twice to get x. So that means that I could have, for example, the cube root of x. That would be x to the 1/3. An example of that would be the cube root of 8 would be 2, because 2 times 2 times 2 is 8. And so we have what we call the nth root. So x to the 1 over n is the nth root of x. Okay? And it's something that multiplies itself n times to reach x. So let's see what that means down here. Well, 8 to the power of 1 over 3, that's the cube root of 8, which means 2, because we can think 2 times 2 times 2 is 8. Okay? The fifth root of negative 32. Well, the fifth root of 32 is 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 multiplied by itself 5 times is 2. And because I have a negative here, this is actually negative 2, because negative 2 to the power of 5 is negative 32. Okay? What about negative 16 to the quarter? Well, because there's no brackets here, we have to do exponents first. So this is actually negative, and then the fourth root of 16. Well, the fourth root of 16 is 2, so this is negative 2. Okay? What about the fourth root of a fraction? Well, if we use our fraction rules and exponent rules, this is actually the fourth root of 16 divided by the fourth root of 81. Fourth root of 16, we already said, is 2, and fourth root of 81 is 3, because 3 times 3 is 9, times 3 is 27, times 3 is 81. All right, what about negative 27 to the negative 1/3? Well, first of all, it's negative 1/3, so that means that this is 1 over negative 27 to the power of positive 1/3. All right, which then means it's 1 over, and now it's negative 3, because negative 3 times negative 3, negative 3 times negative 3 is 9, times another negative 3 is negative 27. Okay? So that's how to evaluate rational exponents. Okay? What about something with a little bit more complicated of a rational exponent? Well, if I have a numerator and a denominator in my exponent, so I have a base to m over n. Well, we know that the over n is the nth root of b, And then I still have this m, which is an exponent m. Okay? And I can say or. It doesn't matter which order we do them in. It could be n to the square root of b to the m. Okay? So either one of those works. So let's simplify this. Well, this is y to the numerator is 2, denominator is 5. This is x to the exponent on x is just a little 1 that we don't write, but it's 1 over 3. All right? This would be a to the negative 3, b to the 4 over 3, and then all of that we did the square root, which means to the power of a half. So now we have to start using our exponent laws. So this is going to be a to the negative 3 times a half. So that's negative 3 over 2. B to the 4/3 times a half. Well, 4 times 1 is 4. 3 times 2 is 6. All right. Now, we know that because this is a negative exponent, we can say that that goes in the denominator. So b to the 4 over 6 divided by a to the 3 over 2. And I can also see that this is a fraction that I can simplify. So this is actually b to the 2/3 over a to the 3 over 2. Done. Okay. What about this one? So this is x cubed y squared all to the power of 1 over 4. Right? So that's x to the 3 times a quarter is 3 over 4. Y to the 2 times a quarter, that's 2 over 4. And so that's x to the 3 over 4, y to the 1 over 2. All right, let's do this part. So cubed root, so this is going to be x squared y to the power of a third times y squared over x cubed. So let's go step by step. First, we're going to take care of this. So x to the 2 over 3, y to the 1 over 3, y squared over x cubed. Well, I can see that the x's are going to be here and here. So that's 2/3 take away 3. And y's are 1/3 plus 2. Right? Because when we divide bases, we subtract. When we multiply bases, we add. So now let's do this fraction addition and subtraction. So 2/3 take away 3, which is 9/3, right? Y to the 1/3 plus 2, which is 6/3. And so this is x to the negative 7/3, y to the 7/3. Now, I have a negative exponent, so that whole thing has to go in the denominator, and my numerator is y to the 7/3. Okay. All right, let's do some evaluating with these rational exponents. So 8 to the 2 over 3, that means the cube root of 8 squared. So cube root of 8 is 2 squared, which is 4. What about the 4th root of 81 to the power of 5? So the 4th root of 81, I know is 3. And 3 to the power of 5 is 243. Okay. What about 49 over 81 to the negative 3 over 2? Well, first thing I notice is that I have this negative. that means that my, instead of doing 49 over 81, I'm going to use 81 over 49 because that negative flips my fraction, right? And so this is going to be the square root of 81 cubed over the square root of 49 cubed. So the square root of 81 is 9 cubed. Square root of 49 is 7 cubed. And that gives me the answer. 729 over 7 cubed is 343. And that's it. Okay, let's see one last bit. We're going to apply all of our exponent rules. So remember, this is all the same base. So when I add the same base, it's going to be x to the 2/3 plus 2/3. And then when I divide the same base, I subtract. So this is x to the 4/3, take away 1/3 is 3/3. So that's x to the power of 1, which is just x. Done. Okay, what about b? So this is, I'm going to apply exponent of an exponent. So y to the 2/4 times y to the negative 2/3. Well, when I multiply the same base, I add the exponents. So this is going to be y to the 2/4 plus negative 2/3. Okay, now I need a common denominator, which is going to be 12, because 4 times 3 is 12. So this is y to the, now I have to do times 3 times 3. So that's 6 over 12 plus negative, and I'm going to do times 4 times 4, 8 over 12. So this is y to the negative 2 over 12, which I know I can simplify to negative 1 over 6. And because it's negative, I can write it as 1 over y to the 1 over 6. All right, let's see this last one. Not last one. So 5 squared, that's 25. And then x to the half squared is x to the 2 over 2. And we'll simplify that in a second. Times 4x to the negative half. Okay, so I'm going to multiply the numbers out. So that's 100. And then it's going to be x, because I'm multiplying the same base. 2 over 2 is just 1, plus negative a half. So that's 100 x to the 1 minus a half, which is a half. That's it. Okay, a couple more. What about, so let's deal with this first. That's m to the negative 6. And then the square root of m to the 4th. Well, that's m to the 4 over 2. And then over m. And then the square root of pq to the negative 3. Well, the square root of p is p to the half. And then the square root of q to the negative 3 is q to the negative 3 over 2. Right? Because the 3 is my numerator and the 2 is my denominator. Okay? So now let's put all the m's together. So this is m to the negative 6 plus 4 over 2, which is 2, take away 1, because that's in the denominator. And then I have over p to the half, q to the negative 3 over 2. Okay, so that gives me m to the negative 6 plus 2 is negative 4, and then take away 1 is negative 5, over p to the half q to the negative 3 over 2. All right. So because this is a negative exponent, that's going to go in my denominator. So m to the 5th. P to the half is already in the denominator, so it stays there. Okay? And the q, because it's negative, it actually moves from the denominator up to the numerator. So q to the 3 over 2. Okay? Because instead of dividing by q to the 3 over 2, we would multiply by the opposite. Okay? So that's how that one works. Let's try this one. So we'll go with x squared to the negative 4, that's x to the negative 8, times y to the 3 over 5, over y, and then the square root of x to the negative, so that's x to the negative 2 over 2, y to the 1 over 2. All right, because the square root applies to the x to the negative 2, and it applies to the y. So now let's do the x's together first. So that's going to be x to the negative 8, take away negative 1, because it's in the denominator. And then the y's are going to be 3 over 5 minus 1, because of that one here, and then minus another half. So let's simplify. So that's x to the negative 8 plus 1. So that's negative 7. And then y to the, I'm going to make all the denominators 10, because that's the common denominator between all of them. So this is going to be 6 over 10 minus 1 is 10 over 10. And then minus a half, which is 5 over 10. So that gives me x to the negative 7, y to the 6 take away 10 is negative 4, take away 5 is negative 9/10. Now, because all of these are negative, right, negative, negative, that tells me that everything is in the denominator. So x to the 7th, y to the 9/10. That's it. Okay? So that's how we do rational exponents, and that's how we simplify everything to do with rational exponents.